Okay, so for Unit 4, Lesson 7, we are going to talk about another way to solve quadratic equations, and this method is called completing the square. So completing the square, the act of completing the square, is taking a quadratic and turning it into a perfect square quadratic. The big thing here is that to make something a perfect square quadratic is that we add the b value divided by 2 and then squared. So I'm going to show that in example 1 because this algebra right here is a little confusing. So I think an example is going to be an easier way to show this. So we're just going to get some exposure to making a perfect square trinomial. So finding a value of c that makes this a perfect square, and then writing that expression as a perfect square. So the value of c that we need to get is b divided by 2 squared. In this quadratic, 12 is b. So it's 12 divided by 2 squared, or 6 squared. So our new c value, the c value that we need to make this a perfect square, is 36. So I'm going to rewrite this expression, x squared plus 12x plus 36. That is a perfect square trinomial. Because if we factor this, numbers that add to be 12 and multiply to be 36, 6 and 6, which is really something times itself, which is x plus 6 squared. So a perfect square trinomial can be written as a binomial squared, x plus 6, x plus 6, x plus 6 squared. So for the guided practice, same concept as example 1. Good chance to pause the video, just get some exposure to practicing this on your own, and then I'll show you my solutions once you're ready. So for guided practice 1 and 2, that is how you complete the square. Divide b by 2, then square it. When we complete the square, that number we add will always be positive because we are squaring a number. When we square a positive, it stays positive. When we square a negative, it becomes positive. So that is the idea behind completing a square. So we are going to use this method to help us solve some equations using square roots. So for this equation, completing the square, the first step I would take is I would move the constant over to the other side, meaning I would subtract 13 from both sides. That's the first step. So I have x squared minus 10x equals negative 13. And if you look at the x squared minus 10x, I'm going to complete that square, which means that's going to be negative 10 divided by 2 squared, which is 25. So to complete that square, I need to add 25 to that expression. Now, since this is an equation, I am going to add 25 to both sides, because to keep an equation balanced, I have to do the same thing to both sides. So this becomes x squared minus 10x plus 25 equals 12. Okay, that equals 12 because I added 25 to that side. This is where our perfect square comes in. This x squared minus 10x plus 25 as a perfect square is, and I'm going to write this over here so we have some room to work, it's going to be x minus 5 squared equals 12. Now, we can solve this using square roots. To solve this using square roots, I am going to take the square root of both sides. This becomes x minus 5 is equal to positive or negative square root 12. And then my final step, add 5 to both sides. So to this point, x is 5 plus or minus square root 12. And I remember before we talked about simplifying a square root. Simplifying the square root of 12, it's really the square root of 4. Do that in a different color. Square root of 4 times square root of 3, which is really 2 square root 3. So totally simplified would be that. So completing the square, writing this as a perfect square, and then using square roots to solve our equation, to finish solving our equation. So I'll give you a minute to kind of drink that in a little bit and think about it. And then we're going to talk about how to solve a different type of quadratic. Okay? So in example 3, if you notice the difference here, our quadratic does not start with just x squared. It starts with something times x squared. So the idea here is, if we look at this, to make this just x squared, I could divide both sides of my equation by 3. If I divide everything by 3 on both sides, it doesn't change the truth of that equation. So this equation would become x squared minus 4x plus 9 equals 0. All right? So now, just like we did before, I'm going to move the constant to the other side. In this case, I'm going to subtract it. And our equation becomes x squared minus 4x equals negative 9. And I've got to complete this square, x squared minus 4x. So our c value is going to be negative 4 divided by 2 squared, which is 4. So what that means is I need to add 4 to both sides. So this becomes x squared minus 4x plus 4 equals negative 5. This x squared minus 4x plus 4 as a perfect square is x minus 2 squared. And that's equal to negative 5. To finish out solving this, got to get rid of that squared. So I will square root both sides. This is x minus 2 is equal to, when we square root, remember plus or minus. Last lesson was about imaginary numbers. Square root of a negative number means I pull out I. So this is I square root of 5. And then final step, add 2 to both sides. So our solutions look like this. X is equal to 2 plus or minus I square root 5. So this unit is dense with information, and a lot of the information connects. So it's important that if you need extra practice, that you try the extra practice that I give you on pencil and paper. I know I don't require it, but if you want to really prepare yourself for those quizzes, it's a good idea to do a little bit extra to make sure that you're comfortable with it. Request Google Meets with me. I will meet with you one-on-one to help you with these. So, guided practice. Again, excellent chance for you to take a minute, try to work through them best you can, look over your answers, compare them with mine, and we can move forward to the next example. But the idea is you've got to be taking these practices seriously to get better at this, to get better at working on the problems without my help. Okay, so to explain these guided practice problems. First thing, if I'm going to solve, make sure that I've just got x squared followed by some terms. I move the constant to the other side, so I subtracted 7, and then I completed the square. So this 16, c is 16, is that c is b over 2 squared. That gives me what I have to add to get a perfect square. So I add that 16 to both sides. I write my trinomial as a perfect square. And then I square root both sides. This one happened to be nice. Square root of 9 is 3. I add 4 to both sides. I got x is 4 plus or minus 3, so 2 solutions there. 4 is the same concept, except I wanted to get x squared, so I divided everything by 2. And I did the same steps as I did in number 3. So that's the important part to remember, is that I did the same exact steps, right? So our last example, example 4. This will round things out. So I'll have this example, 2 more guided practice, and then you're ready to move on. So this is going to be a little more rare, but I'm still going to show you this example. Writing a quadratic into vertex form. So for this, we are going to be still doing completing the square. It's going to take on a little bit different format than what we did before, but it's the same basic concept. So we've got this trinomial. What I want to do is I want to complete the square for just this part, and I'll show you what I mean in a second. So to complete this as a square would be, find my c value, it's 14 divided by 2 squared, which is 7 squared, which is, 49, okay, 49. So what I am going to do is I'm going to add 49 to both sides in a specific way. So don't skip ahead. I just want to show this. So this becomes y plus 49 equals, and I'm going to write this perfect square in parentheses. I'm not going to combine my like terms, which seems weird right now, but just give me a second to explain that. So I'm completing this expression as a perfect square. So what happens is, I'm not solving anything yet. I'm writing this as a perfect square. This is x plus 7 squared. And then tacked on the end is that 44. So it's kind of ignoring the c value, ignoring the constant, completing just this square. And then here, my only last step here is to subtract 49 from both sides. So this whole thing is y equals x plus 7 squared minus 5. And that is now in vertex form. So it's completing the square, but in a targeted way. So whatever I complete the square with, I complete the square, and I leave this constant on the end alone for a bit, and then I write my perfect square and solve for y. So it's a little more in depth, but this one is just a little wrinkle to completing the square. So in the guided practice, again, take a minute, pause the video, try them, and then check your solutions with me. Okay, so to explain these last few examples, I'm just going to walk through how to put this into vertex form, and one thing I just wanted to add here is that I should have said this before, but identifying the vertex is something I want to review with these last two. Sorry, if you didn't do that, that's okay. I should have been on that earlier. But completing the square, we're just completing x squared minus 12x as a perfect square. So that means I add 36, okay, to it to complete the square. So the act of completing that square and then solving for y. Same thing on the other side. I'm just completing x squared plus 16x is a perfect square. I use 64, and I targeted that perfect square, wrote it as a perfect square, and then solved for y. So this one, again, is a little more rare, but I think it's still a nice thing to know because it gets you practice completing the square. So long video, okay? I'm going to try and give you a practice that makes sense, but remember, take your time on the practices, ask questions through email. If you want to set up a Google Meet, we can do that. But the main thing is that you're trying a lesson a day. If you're falling behind, try a couple lessons a day and keep at it, all right? My goal is to finish Unit 4 before we get to Christmas break or winter break. So that means next week you're going to be finishing 4.8 and taking the quiz to be on pace. So do your best to keep up, all right? And I will be open for help in any way I can.